Hello everyone and welcome back to another episode of GhostEngine devlog series. Today I was planning to go into a more advanced topic like the querying system for our ECS. We implemented like 2/3 of the ECS system, but I decided instead to go with something much not necessarily easier, but it's something that, if done right, will help us in the future to have more maintainable code. So, maintenance. The topic for today is maintenance. Now I created this user story a while back where I collected a few areas of interest, and we want to work in a particular order. I will start with this one with using downcast RS for creating downcast helpers. If you remember from our, I think even in the last episode where we worked on the ECS system, we used downcasts, those helpers. So in our trait we required an implementer of the trait to define those functions that were basically returning a reference to self, but cast it to a reference to any or a mutable reference to any. Me as a consumer of GhostEngine, I wouldn't like to have the need to define those by myself. So while I was reading about Rust, about doing things in a better way, I found out about this crate downcast, this one. So let's go ahead and try to use this one to make our code much nicer. So let's add it. Well, no, first of all, let's create a branch for our work. So create branch, periodic main. Okay, I'm just gonna copy it from here because I'm always butchering this word. Okay, the branch is created. Let's go again. So we copied the dependency. Let's take care of the ECS crate first. So let's add it, save that one, and now what do we need to do to make our life easy? So let me see. I think, if I'm not mistaken, this is what we need. Okay, so we need this downcast, we need our trait. In this case, this component bucket trait, we need it to be downcast in debug, and we need this to implement this for the trait. Okay. Let's see to that. And for those things we cannot resolve. Okay, just don't freak out. I think I need to restart the language server. Sometimes it's not picking up everything. Well, the compiler, yes, it's telling me to use this, so I'm just gonna do it manually. I don't know why the suggestions, it picked up. So let's import that, and also need to import this macro. Okay, let's save it and let's delete that. Let's remove those. We have some unused. Remove unused. What else do we need? We don't have args in our code base. So I think that's all for the ECS crate. You know what? I think I'll do a search. Wait a second, what's going on with my Sublime user interface? So let's search for as any. Oopsie, function as any. Okay, where do we have it in application? Okay, so let's do the same thing, but for the core GhostEngine crate also. Okay, save that, close, and let's remove that. We require the application runner tray to be downcast. Okay, we remove this. What else? Okay, did not pick up, but I'll just copy those two. Okay, there. Not there, but where are you? This macro invocation. There. Okay. We should be covered now, but of course that's not component bucket trait, it's application runner. Okie dokie. Let's see what's next. Again, let's restart the language server. Of course, we don't need that. This goes away too. What else? This one goes away too. You see, we already cleaned a few places where we were required to implement those methods, but we wanted to get that functionality for free, not to just implement them because the trait interface requires them. Okie dokie. Next, let's search again. And we have the resource trait. I think this one might be... This one actually would Wait a second, we implemented this trait because we wanted to have this trait, something that implements this trait stored in this hash map. And we wanted to have downcast capabilities for the resource. So let's remove those functions from the resource trait itself, and instead let's require the resource trait to be also downcast. Okay, like that. And how was it? I'm not used with that macro, so let's just grab it with copy paste. And that, let's import the macro. Now we just implement the resource trait for resource T, and we should all be set. Okay, let's remove that. Now let's check it out. I'll use the continuous integration checks. Okay, stuff is failing. Why? Why are tests failing? Add component to single entity. Okay, let's concentrate on this test. So cargo test. I think it's enough to just specify the. Yes, it's enough. So panicked. So this one panicked at line 240 in the ECS, line 240. So it panicked here. So we are going here. We calculate type ID. Okay. I think everything breaks at those downcasts. Let's just take a look at this one. So the downcast trait requires the implementer to also implement any. So this one converts a reference to our trait, where the trait is downcast, to a reference to any. Also we have into any and into any RC. Into any convert box dynamic trait. Okay, let's check the. So our bucket is a boxed trait. Okie dokie. So we are gonna use into any. I'm not satisfied. So at this stage, bucket is a reference to a box. Okay, let's go with this into API, into any, and then we downcast it to a boxed vector of an optional type. Cannot move out of bucket. No, we don't want that, but instead we use as any. It's weird that, for me at least, it's weird that the Rust compiler is not complaining, but at the runtime everything breaks. So let's see a full stack trace for this one. We have to run it with this environment variable. So let's add it to our command line here. Okay, so what do we have here? Function panicking. Okay. So we have our tested component. So we have the closure in our lib line 234. I don't understand. So line 234. So 40 is this one. And then I don't understand. So the closure. So closure at line 234. Okay, maybe this one is transformed in a closure by this test macro. Okay, whatever. Okay, I'll just add some debug annotations. What I'll do like this, because I want to also take this one. Actually, I want to drop it in a debug macro, and hopefully it will cooperate. Okay, save, and let's run it again. So the downcast fails, but downcast returns none. Okay, let's see the documentation here. Maybe we are missing something about the usage. Okay, so here we have a boxed base. So base is a trait. Okay, base is a trait. Next. So we have a boxed trait, and it's fine. Then we have a boxed concrete implementation of something that's base. In our case, for this one, and they are doing base.downcast ref. So that's exactly what we have here. Our base is a boxed something, and we want to okay, so let's get back to the code. I thought this usage of downcast RS crate would be something easy to kick off our maintenance episode, but it turns out not really. Okay, but why? I think I know why. Because our no. I think we also need this T to be downcast. So let's see a little bit. We have our trait. We are implementing stuff for it. Okay, we are implementing debug. No debug. We are implementing component bucket trait for a vector of optionals. Okay, that's fine. Now the big question is why we are failing this is downcast. Is it because you actually want to work with that stuff? With an actual box and not a reference to a box? And what do we have here? Cannot return value referencing local variable bucket. Returns okay, we don't like that. What if I'm just doing it like this? Not happy. It is not happy. And that goes away. No, he's not happy about it. Let's try and go with a boxed. We will make use of this into any stuff, and then we downcast it like this. And now what's wrong? Yes, it's the same problem. Cannot move. Yes. So converts a boxed trait to a boxed of dynamic any. Yes, we don't want that. Actually, we want as any. But that downcast will fail. And my question is why? Why that would fail? Will you fail because you actually expect something here to be downcast. Trait object must include. Okay, then the downcast ref method cannot be invoked on a trait object. Fair enough. So you need mutable that instead of that. Huh? This is something I really want and I want to fix it. Even if I publish this episode only with this problem solved, but I want to fix it. So in our case, our base is component bucket trait. And you are implementing component bucket trait for a vector of optionals. Why would the cast fail? What's happening in this macro? Oh, come on. Ooh. Wait a second. Let's go back here. Great. I saw something in the comments, but I wanted to see it here because it's clearer. With concrete type, so we have a trait. Okay, let's try this one. So that expect no, we don't need that. Those are for generics. As far as I can see, we have this trait and we give it a concrete generic. We give a concrete type for the generic parameter. So that's not what we want. So we are following what they tell us. And we implement downcast. Okay. You know what? I think I'll go in our source code. Something fails here. Okay, what did I break here? Okay, go back to that. Okay, this test will fail, but what I'll do, I'll add a new test. I'll call it boom and define a trait. The trait is exactly that, base, and I will implement base base for vector of d. Okay, that's everything. And I require this to also implement downcast. What else? We call that to implement downcast macro with our base trait. Okay, that. Back to the documentation. When we have a generic type with types, no, our trait is not bound by a generic parameter. So what's wrong here? Consider adding an explicit lifetime. Okay. That. Okay. Now let me create a box, not box, that's a reserved word. Nay, that's a boxed vector of your sizes. And default. Yes, that's all. So now we have a boxed vector of your sizes. And I'm actually forcing A to be a boxed dynamic base. So A at this point is a boxed base. And if we do as any downcast ref, and we are downcasting it to vector of use size, it should be happy about it. Okay, let's try this one with our boot test. Okay, now the test runs okay, but what I would rather do, I would have our let mutable v equals to that, and v dot push value, I don't know, 12. We have that, we boxed our vector, and what else? We now have that, and we want to unwrap and to get our first to print our come on. And things are not working, you can't type fast. So we have that. So let's check it out. Okay, it fails. And it fails because we get none from the downcast. Now the question is, why do we get this none? Because honestly, I don't know why that happens. Cargo okay, I want to use cargo expand to expand the macros to see what's actually generated for that for this implement downcast stuff. So cargo expand test blue. Cargo install cargo expand. Okay, let's install that. Okay, let's wait a bit. Okay, now let's try to expand cargo expand manifest path. Okay, is a virtual manifest, but this command requires running against an actual package in this workspace. So let's cd to our ghost ECS crate and do an expand. Nice. We also get highlighting. So our no, it's somewhere at the top. So we have our entity record, our entity bucket trait, and we have this implement dynamic bucket trait. What? I'm starting to feel that this is a bit out of my league. So we are implementing this. We are defining those methods. So what's the difference between downcast and downcast ref? Returns a boxed object from a boxed trait object if the underlying object is of type T. And it returns the original boxed trait if it isn't. Okay. So this one is using the SNE from downcast and it downcast it to our T, and our T is something that implements component bucket trait. And we have this. Oh, I think I get it now. So let's follow this and the code for more test. So this one, so when we call downcast ref here, so maybe I don't need to call that, and actually that's enough. Problem solved. So the solution is instead of going our boxed trait as any downcast and so on, we just go directly here, boom, and it should work. Okay, let's keep for a while this test for reference. Now let's run again the full suite of checks. Let's get to the root of our repository and let's run our checks. Okay, so we have this test, this one, where we have as any. We have it in a lot of places, but let's go to that test again. So we have this, we have add component, has component, I think it's the culprit here. Yes, it is. We do this instead, and now, if not all, at least a good part of the tests should be happy. Let's see what's wrong with that test. So that test is it's creating entities, is adding, is removing, and is using has component. I think we also need to check this one. Yes. We get rid of that. And we check again. Where's the test? Add, no, this is can remove, can remove. Yes, we fixed it. Let's go like that, test by test, and fix them. This one, let's see where the problem is with this one. It's down here. Oops, we did it a bit more than we wanted, and that's it, I think. What the okay, that's okay. We test again. Something is still failing. So we fixed has component, didn't we? Yeah, so we fixed it here. Maybe it fails even if we do that. Okay. Okay, let's go back to the Let's go back to the test. Actually no, we will be focusing test by test and use the full back trace. Actually, let's put it to full. Okay, a lot of noise, but it should be good noise. So now let's actually go with just one here. So we have our test. Two hundred 255. Where are you? 255. This one. 255. That one. So 255. 244. Okay, this one doesn't help me. Okay, let's go in add component. In add component, so we go to the key, so on and so forth, as any mute. Ooh, I think this one goes berserk. I think we actually need that. Perfect. That one is covered. Okay, a lot of more tests are passing now, so let's focusing on this one. Add components. So get component should be our yes. Here's the problem. Save and check again, and everything passes now. Okay, even the code style. Nice. Oops. So let's remove this test. Save everything. Test again because I'm paranoid at this point. Okay, everything works. So let's stage everything and call it a day for the usage of downcast rs. Use downcast rs to implement support for downcast casts. If I can type. Oh, I actually typed well. Okay, now that is done. So we are done with this one. Clarify naming conventions of trait versus wrapper structs. I think we are using wrapper struct in our unit tests, but for traits actually this is a valid point. We need to clarify the naming convention. In application, here we have the application runner, which is called just application runner. In resources, we have resource trait. So, and also I think we have another thing here. Yes, this is one is comp and bucket trait. In a way, I like to have trait in the name, because I know for sure that we are implementing a trait, and this is not just a struct, so we know it's a contract, it's an interface. What I saw in the Winit implementation, they are calling different traits, some trait X, for example, but they are using traits to extend the implementation. So we are not using this to extend implementation of a struct. So I think I will go with this naming convention. We can always change it, but for now I think this one is the best thing to do, or not. Actually, you know what, let's go to a crate. Let's go to Winit. I mentioned it. Now the thing is that the Rust documentation system that generates and renders this documentation, it's quite nice, because if I go to a struct, I don't know, let's go to window, and I think this is not a good example. So let's go to platform. Okay, Unix. You see, the documentation separates enums from traits, from structs and so on, even if they are defined in the same module. And we are also, when we have code like this, implement something for something, we know this is a trait and this is a concrete struct. So you know what, I decided to not have this suffix, so that, and let's see where we have traits defined. So we have this bucket, this component bucket trait, application runner, and resource trait. Okay, let's rename that. Okay, if we rename that to resource, I think we'll have a problem. Yes, because you also have this wrapper struct. But you know what, actually don't need that. Actually don't need that, because we can get rid of this wrapper struct, implement resource just for T. Just a second. Yes, I think we need those. Let's just copy that. Get rid of that and go. Oh, actually, we have those trait bounds here. Remove that, and now it should be happy. Okay, more cleanup. Okay, so let's go like this. Select that. Okay. No, it's not a good idea. That and that. Next. Just T here, not resource T. Oh, and yes, get rid of this line of code too. Same here, delete that, and just that. Next, I think that's everything, so let's check it out. Okay, this one is okay, so let's commit. Let's do a code review. Okay, we rename this. You see, actually this resource struct we defined actually was a wrapper struct, but we actually don't need it. As long as our T implements default and has a static lifetime, we just implement resource for it. And yes, resource just requires us to have this downcast trait bound. Ooh, wait a second, let me check something. Maybe we can even get rid of this resource trait now, if I look at it. Because we can just go like downcast there. Bear with me. Let's just comment that. Okay, and okay, that's but the tests are passing. Do we get a benefit for well, if we use downcast here, we get the benefit that we don't need those things here. So we get a bit cleaner code. But if we want to, you know what, this one I want to debate it now. I will just restore this to that, and actually I don't understand why I can't do this, to be honest. I don't understand. So downcast is a trait, okay. Default is a trait, but it's telling me that the trait is not object safe. What if I also require this to be sized? Okay, and we have a problem with this one. Traits, the trait resource cannot be made into an object. This error originates the Mac. Okay, cannot. Yeah. I would really like to have a trait bound like resource, you know, and just have that. For now I'll just go like this. If I put this one there and require this to be resource and default. Okay, that looks to be nice. This one, overflow evaluating the requirement resource required for the object tagged in resource. Huh? Ah, yes, because I'm defining a resource trait here and okay, I'm digging a rabbit hole here. Let me go to this and make sure everything is okay. Yeah, so we have that. Let's commit. So use something as a trait name instead of something trait, and also remove the need for the wrapper resource struct. Okay, let's stage everything, commit, next. So we clarified that part, clean up the ECS crate. Now let's take care of this one, separating the application runner and the application into separate modules. For this one, okay, so let me close everything and just open application. You see here in the application module we have a bunch of things. We have the application runner trait, we have the implementation of the run once runner, we have our application itself, and that's everything. Also the unit tests. The thing is that we want to, as users of the GhostEngine API, we want to have what's in the application namespace to be available there. But me as the maintainer of GhostEngine, I would like to have those things separated. So what I will do is this. I will create a folder, application, okay, and actually I would go ahead and create submodules for each component of the application module, and from the application module, the root module, I'll just export them. So bear with me while I'll do it. So new file. I know this might not be idiomatic Rust way of doing things, but damn it, if it makes my life easier, I'm happy. So application runner, this one, application runner. Okay, so let's take this. Let's take that and dump it here. Okay, we need to insert that. We will deal with them later with what we are exporting from the application module. Next, the run once runner. We create a new file, so new module, run once runner.rs. Dump that there. Insert that. Application. Well, this is debatable, but I will just go like this. Dump this here, save application. Okay, and yes, let's add the node application stuff. Now I think I need this tab use application everything, applicate that, and run once runner and application runner. And the unit tests, to be honest, even those I will move them in a module dedicated to them. But for now, I think we are testing both the runners and the application. So I will split them. I will move what's about the runner in the run once runner part and what's for the application in the application. So close that and open that. Should I go like that? Yeah, just go like that. Okay. What else? This one. Okay, import that. Import that. Import the other stuff. Ooh, nice. Okay, so we arrived at the tests. So I will get that test, this test, this test. Okay, so those tests are about the application. So let's move them down here. Mod test mode. Paste that, save. Next, can run application with a same custom runner. So this one is also about the application. Can run application with, are those the same? Oh no, they are not the same. Here the runner executes the application, and here the application executes itself with the runner, with the use of the runner. Okay. And I found something else we should take care of, but at the end. Okay. Application, doing stuff with application again. So everything from here is about application. So let's just get that, delete this and move it here. Oops. No, that's fine. Okay, let's check it out. Module has the same name as its containing module. The further information. Let's see why. So check for now. Okay, a typical beginner mistake is to have mode full and again mode full in full.rs. The expectation is that items inside inner mode full are then available through full --x, but they are only available to full --full, well, not dash, column. Okay. If this is done on purpose, it would be better to choose a more representative module name. Well, I'll just ignore this one, so go away, go back here, and this one, and with this one I think I need to be here at the beginning and say what was the syntax? Allow this. I think that's it. Yes, that's it. I just work better this way. Call me a Rust blasphemer, but for me it's just easier. Okay. Maybe I'll just even transform this to the old way of defining module in Rust and have it at mod.rs inside this folder, but for now I'll just go like this. Next, let's see about the resources. So we have a trait here, we have an enum. We have the resource manager and the tests. I'll do the same for resource too. So, new folder, resources. Okay, new file, and what? Resource manager. Oh, no, save resource manager. No, I'll go away. Okay, insert that. And I'll copy everything, including the tests, because those are about the resource manager. So that, and paste it here. Next I will take this I want to be consistent, so I'll create a new file for this one. So a new file, here in resources, resource creation error. Maybe if we gather a lot of error types, we might have a module dedicated for them. So we have that, no, this, we take that, we paste it here, we insert that. What else? This resource trait. This actually makes sense to now. Now the thing is that this implementation, it's about the resource. So let's move everything. Also we now we'll just insert what's needed after. So a new file, save, put it in resources, and this one is not there here, resource.rs, save, paste. Okay. Oh, I butchered the name here. Okay, rename resource. Now it's fine. Import that. Oh no, go away, go away. No, delete, and yeah, resource, and we do pub use resource everything. Creation error, everything, or manager, everything. Source. Okay, well covered. Now here, import that and import this too. What else? Ooh. What do we have here? Here we have a lot of stuff we need to take care of. Okay, let me restart the language server. Are you okay, dear language server? Seems okay, so let's check it out. No, a lot of stuff is not okay. And I think I know why. Well, no, resource manager. Okay, I'll just manually go and add them. So use std collections hash map for once. Use std any type id. Use super resource. those two can be merged. Okay, import that. What else? That's all. Okay, so the tests are passing. I don't know, I just feel that's beautiful. I don't know. And here, for example, at some point I can just come here and write to module level documentation without having a ton of documentation and implementation code. Is the way I work best. So let's do something similar also for the ECS crate. But actually, I will. No, I'll do it now. Okay, so for the ECS crate, it's a bit. No, it's actually easy. So we have a new file. We call it universe.rs, and we just take the universe struct with the implementation, the tests, everything. We take that and we just dump it here. We add the pubmod universe here, and we do pub use universe, everything from the universe module. Okay, remove unused imports. We also move component bucket trait into its own file. Component bucket, that, select that. What we have here, like that. And here we have component bucket. This is unused. This is unused. About those, I'll move them in the universe crate. Well, actually, no, they are used. They are used even here for the entity record. Okay. Okay, so actually those I will leave those here at the root module level and move this one somewhere else in the universe. Yes, I'll move it here. I'll move it here. Create index, okay. Create entity ID. That one. That one. Component bucket. Okay, we need this trait to be public. Also need to import a bunch of stuff. This one for that, and for this one I think we need use std. Oh, come on, debug. No. Oh, come on, debug. Let me try to compile and, well, no, this one. This one. So copy that. And that it there, save. Now it is happy. Oh, what do we have here? This is about collections, hash map entry. Yes, hash map entry. Okay. We also have debug here. Do we need that? No, we don't need that here, so go away. Component bucket, import it. Nope. Nope. Again, no. And that goes away too. What? Required because this one. Go away. You go away too. You go away too. Okay, so let's check. Okay, everything seems nice. Let me search for debug. Debug to see in which context it is used. If it is used like derived debug, then it's okay, and we have only that. Okay, perfect. So let's commit, and we stage everything. We stage all the new files, and we call this reorganize code in almost one file per type. I know this might not be the Rust way of doing things, but at least for me it is much easy to maintain. Okay, we have that. Next, so we took care about this one and the ACS crate, so we cleaned this up too. Make running unit test more compact. Okay, we don't do that. Document the code. We won't go into this. Actually, I will document the code off camera. Or maybe I'll do a second maintenance this sprint. Yeah, so I will finish for today. To be honest, I don't know how long this episode will turn out to be. Thank you for watching. If you enjoyed this journey so far, like, subscribe and click on the notification bell. Until next time, bye bye.